Hello and welcome to this video on astrology, or perhaps more accurately, debunking astrology. Astrology, by definition, is the study of the positions and motions of various celestial bodies in the belief they have some sort of influence on the course of natural occurrences on Earth and, to a greater extent, a human activity. A somewhat long-winded way of saying that stars light years away from Earth influence your daily life. Taking the premise of astrology at its face value and assuming the most generous possible circumstances, let's start taking astrology apart piece by piece. First, we have the idea of celestial bodies. This part of the definition seems to only apply to planets and stars, but why not satellites? They are arguably just as much a celestial body in this context, as it's based on an arbitrary point of light being chosen. Well, arbitrary as any other point of light anyway. The advantages to a satellite, and arguably the only advantage, is that they are most definitively there and active. This leads to a problem for us. More than half the stars in the night sky are long since dead. We just don't know it yet. The light takes that long to travel to Earth that they appear to be there, they appear to be alive, and at least arguably active, but they're long since dead. Because of this, we have two problems. One, that light takes, light years to travel to Earth, and so does gravity, the other aspect people claim affects life on Earth. If we assume just our own sun's soul as one source of light and gravity, we can see the effect here. It is rather straightforward. In fact, we see it easily in the day-night cycle. Gravity is demonstrated through our annual trip around the great big ball of fire we call the sun. This leads to the second issue. What if we now add two more stars? First, let's operate on the basis of being trapped between the three equidistant stars. This is to keep the initial model simple. If, as Earth travels around its orbit, there was a variation in how much exposure we had to light, we would get, far more variation in the seasons. Not 4 seasons, but theoretically up to 12. That is, each of the exposures Earth has to the sun that it's close to at that time would cause a difference in the season. We rather obviously don't see this, but it would happen with 3 equidistant stars. Our orbit would be incredibly disrupted, more so than it is now, and that is due to gravity from each star pulling Earth further towards it as Earth went through its orbit. A more realistic scenario has Earth orbiting Sol, our Sun, and there are a range of stars further away from Earth. This is more in line with what astrology claims. This has a certain advantage to our model, and that is it largely mitigates the effect of gravity, as, to be quite blunt about it, the amount of gravity from the other stars is so little that it has no effect on Earth relative to our own Sun. With that in mind, let's look at what happens. To keep it simple, we'll start with operating on the basis of Sol being the center, Earth in orbit around it, and 3 stars further out, but again equidistant. This has one major advantage. It means the effect of gravity on Earth becomes practically negligible as stated. But for the light, Sol is obviously going to take and give the most. This accounts for the vast majority of exposure. The other 3 stars are now the next brightest objects to consider. As they are equidistant, we can take one and apply the findings to the others. If they are the same distance from Earth as the nearest star, Proxima Centauri, we can establish how much light gets to Earth from these distant celestial bodies. Proxima Centauri is 4.2465 light-years from Earth. This is roughly 40 trillion kilometers or 25 trillion freedom units. It has a light magnitude of 11.13. This is a direct measurement from Earth, so we can work on the basis of this being the actual light that gets to Earth. And now if we apply this to all 3 stars, as they are located in different directions and offset by 120 degrees from each other, the light hits Earth in a different way. That is where you are on Earth will experience different degrees of light, which is what some argue is what has the effect on Earth based on astrology. To get the results we do require a little math to figure it out, but it is relatively straightforward. First, we have the angle of Earth from the star in question. It's a rather straightforward example of trigonometry. It is the a half of the Earth exposed to light as diameter. We use this and we can figure out this is how much light is getting to us, and then based on any one of the 180 degrees on Earth that is your location, relatively speaking, we can figure out how much light is present. With the stars being offset by 120 degrees, we can now figure out how much light they emit that will hit Earth from where they are using the same process for the two stars that don't face directly to that half of the Earth. This means that the three stars will emit light, and this affects you in the following ways. This is all based on a rather straightforward model, and you can see that the amount of light that will hit you isn't all that much in the end. Now we're going to make things a little more complicated. Rather than have the stars the same distance from Earth, they're going to be different distances. This slightly more complex scenario will be more difficult, as we can't just use the same result and adjust by the amount of Earth surface overlap between the stars. This is because each is a different calculation entirely. The same basic formula, but different calculation. So we have the closest star, which for simplicity we'll use Proxima Centauri again, which we have a known value for. It is the same as last time. And next we have Bamad star, which is 5.9629 light years, and an apparent magnitude of 9.53. The final is Wolf star, which is 7.8558 light years away, and an apparent magnitude of 13.44. We now apply the same approach as previously. That is, calculating the amount of light that gets to Earth first, then how much that light affects a given side of the Earth and the overlap. We can then divide by 180 to get the rough, and understand it is a very rough idea, about how much that light would affect you as an individual. 3 stars is honestly not a very realistic example, as there are many more stars in the night sky than this, in fact, during the daytime as well, but that's not really what astrologists argue. The next issue is that these are just the stars that are visible to the naked eye, and under those circumstances, we're ignoring a lot more stars that are out there, and that's an issue. Astrology does not account for all the other stars that aren't necessarily visible that would arguably have the same effect if astrology was to hold true. You can see an increased number of these stars if you're in a light desert, and in that case you would witness many more. By contrast, if you are in a major urban center or similar where there's a lot of light pollution, you would see far fewer. And this is the problem here. If we start to apply this idea by adding just a few more stars each time, with its own unique value and of light magnitude and its own unique distance from Earth, things get very, very messy very quickly. But importantly, the value is tiny relative to the magnitude of our own star soul. That is to say, far less politely, that astrology, if you were to try and argue that one small grain of rice on a scale is going to change anything by comparison to a much larger weight, honestly no. It doesn't matter how many grains of rice you add, so long as we're talking relative terms here. And now we can apply much of what we've already said to gravity, and that's because, to a certain extent, gravity travels at a similar speed to light, and, to be honest, the effects of gravity from these distant stars would likely be as, if not significantly less, impactful than light would be. That is, relative to the effect of gravity from other stars, they are tiny by contrast to our own, and why only some selected stars have this impact. While they may not be the stars that actually have an impact on us, it's a relative measure. And that's the issue. Why does astrology not only claim, but expect only certain stars or other celestial bodies affect us, when all other stars or planets and so on would have exactly the same effect, but according to astrology, they just don't? It doesn't make sense, and that's just a purely logical failure. The next major issue we have, and this is one with our model as we've made it so far, and that is, so far we've described everything on the basis of there is absolutely nothing that would interfere with light traveling between these distant objects and Earth. There is no variation in output or any other problems. But that's not how the universe exists. Within the universe there are things like gravity, black holes, planets, other stars, and more. All of these would not only block the light, but they would also distort it, shifted away from Earth, and more. And all of these things, if put more simply, would further reduce the light getting to Earth than what we have calculated. Think of what happens when the moon gets in between the sun and Earth. A lunar eclipse perfectly demonstrates the issue with the model that we've presented so far. That is to say, no matter how we were to do this, there would be an even further reduction in the amount of light that would arguably be affecting Earth. This is why on its surface, and assuming the most realistic and viable explanation of astrology, it still fails. And not just fails by itself, even if it were true. It's the selection of stars makes no sense, as they are not the stars that would have an impact from gravity or light to start with. And even if they did, and that is a massive if, what about all the other stars that would have an effect, and yet for some reason astrology believes they don't seem to count? Yeah. There's a big reason why astrology is just pseudoscientific nonsense. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.